We've got a problem where we have some ice that's melting and perhaps warming as well. We know it's going to start melting right away because it is at 0 degrees Celsius, and that is the melting slash freezing point of water, same temperature. And so we know that we're right here where I have this pink dot. As it melts, we'll do our calculations based on the heat of fusion. And then if it all melts, if we have enough energy to melt it all, then we'll use our usual QSMAT to do those calculations. Okay, so I'm just going to assume that there's enough heat, the 20 kilojoules is enough to melt it all. What we should do maybe is say, well, how much energy does it take to melt all of that? Well, I have the heat of fusion is a conversion factor. So I'm going to start with, well, how many kilojoules does it take to heat the 50 grams? So I could just do, so this is for melting, 50 grams. Of course, this is ice. And that's in moles, kilojoules per mole, so I need to convert to moles. And then from moles, I can go to the amount of energy it would take in kilojoules. Okay, that's how much energy it would take to melt, and it looks like I have more than that. So it looks like all of the ice is going to melt, and then at that point any additional heat will go to warming it. So let's now look at warming. Now that it's all liquid, and that equation, of course, is just our usual equation with our specific heat. And one thing I should warn you about is this is warming liquid water. And so the specific heat that we use a lot, 4.18, that is the specific heat for liquid water. But be aware, if we were having to warm the ice first, then we would have a different specific heat for ice for a different phase. So what I'm saying is in this phase, you need a different S specific heat than this one, and same with gas. Anyway, so, but we know this one because we use 4.18 quite a bit. So, well, so how much, I need to know how much I have left. So I used it 16.7. Let's just do a little calculation over here. So I started with 20 kilojoules and I used 16.7 kilojoules to melt it. And so that leaves 3.3 kilojoules left. So now I can plug into this. Another thing I need to watch for, you guys, the specific heat is 4.18 joules per gram degrees C. And I've got a little of an issue here because this is in kilojoules and this is in joules. So I need to make sure that matches or it'll get me in trouble. So I'm just going to convert my 3.3 that disappeared. 3.3 times 10 to the third joules, just to convert that. The T2 times 0, this is the T1 is 0. So anyway, just algebra after that, just this number divided by all of these. The 0 kind of simplifies pretty easily. And I get a T2 of, with 2 sig figs, 16 degrees Celsius. And so the main thing on a problem like this is that you have to just break it down into steps and see what, how much energy it takes for this step, and then you calculate the next step. So, and it'll always be as it's warming, you're using QSMAT. As it's melting or going through a phase change, the temperature will remain constant, and you'll be using a heat of fusion or a heat of vaporization if it's up there.